Hi, my name is Simon Venkatesh, and today I'll be discussing Benzofury, a drug with hallucinogenic properties that can cause you to dream of a movie like Kung Fury, a 2015 1980s-esque martial arts time travel Nazi killing movie by David Hasselhoff. I've thrown in some references to this movie for the sake of comparison. Now, Benzofury is called this because the drug's active ingredients are based on benzofurans. It is important to note that benzofurans are not the same as benzodiazepines, although both are often called benzos. Both begin with a benzene ring, but benzofurans also contain a furan ring, which you can see on the top here, whereas benzodiazepines also contain a diazepine ring, which you would see in the bottom here. Together, these make benzofurans on the top and benzodiazepines on the bottom. The differences in these structures give each class of drugs different mechanisms. Benzofury is a tricky drug to study due to its different chemical composition. It can either appear in its 5-APB form or a 6-APB form, and sometimes little-known 4-APB form. On the left here you can see 5-APB, and on the right you can see 6-APB. Both forms of the drug seemingly have similar effects, though it is difficult to isolate their effects due to users of the drug often not being able to know which form they are taking. User reports say 5-APB is more potent than 6-APB, and that 6-APB is the most common form. But again, these reports are flawed by the earlier point. Moreover, Benzofury is made synthetically and only emerged in the market in 2010. Thus, there has not been a lot of time to actually study the drug. Benzofury became available to buy over the internet mostly, but also appears to have been sold at music festivals. From user reports and news stories of deaths, it appears the drug was mostly used in music festivals such as concerts and raves. The drug mostly appeared to come as a white or brown powder or as capsules, as one can see to the right. It was classified as one of the UK's legal highs. These were drugs that were marketed for research purposes and labeled with not for human consumption. This allowed these drugs to get around the UK's laws regulating them. Eventually, the molecules in benzofuries were banned, so now a cop like Triceratops can arrest you for having it. This occurred after a series of high-profile incidents in which users of the drug died. This included Alex Harriott, who died after taking the drug at a music festival, and a graduate student, Jennifer Whiteley, who died from a combination of drugs including benzofury after celebrating her new job helping drug addicts and people with depression. Moreover, the UK's Home Office identified 27 psychoactive substances since 2011. Deaths involving legal highs also increased by 80% from 2011 to 2012. Though this amount doesn't say too much due to the already small amount of deaths from legal highs. In fact, the amount only increased from 29 to 52 during the span of these years. However, fear of synthetic drugs spreading and becoming more popular are real and true. Additionally, the drugs were banned in order to send a message that drugs are truly dangerous. Even drugs 5-MAPB and 6-MAPB were banned due to their structural similarity to 5-APB and 6-APB. Many of these deaths seem to have resulted from combining the drug with alcohol or other drugs, though there appears to be some deaths solely related to benzofury as well. When it comes to behavioral effects of benzofury, there isn't a definite consensus on an official set of symptoms. Due to the little amount of research on the drug, many reports of symptoms come from small sample size user reports. The reported symptoms of the drug are visual and auditory hallucinations, nausea, agitation, feelings of increased energy, temporary feelings of love, dilated pupils, raised body temperature, increased heart rate, tightening of jaw muscles, and insomnia. To the right, you see an example of a possible hallucination, much like the entire movie Kung Fury. Moreover, experiences on drug forms indicate that benzofury produces euphoric effects that are long-lasting. The most common comparisons to the drug are to amphetamine and ecstasy. Indeed, there is seemingly some overlaps between these drugs and benzofury. Ecstasy also produces raised body temperature, euphoria, nausea, increased heart rate, and temporary feelings of love. Amphetamine also causes feelings of increased energy, euphoria, anxiety, nausea, and increased heart rate. Speaking of amphetamine and ecstasy, another reason why benzofury is compared to these two is because of the comparable chemical structures and binding. Here, the top left molecule is 5-APB and the top right is 6-APB. In the bottom left is MDMA ecstasy, and on the bottom right is amphetamine. Ecstasy has an additional methyl group on the nitrogen atom, as you can see right here. And there is an oxygen atom in place of a carbon on the furan ring. Amphetamine simply completely lacks the furan ring. As for similar binding, I'll talk about that after discussing benzofury's specific effects on receptors. In a 2013 by Iverson et al., the molecules identified as benzofury, along with other psychoactive compounds, were tested against a variety of human receptors to find binding using a variety of assays. In this experiment, both 5-APB and 6-APB were found to inhibit the monoamine transporters for norepinephrine and dopamine. 5-APB was also found to inhibit the monoamine transporter for serotonin. All this is verified by the low Ki values for the drugs in their respective categories. Compounding the structural and symptomatic comparisons of 5-APB and 6-APB to amphetamine and ecstasy, ecstasy was found to either inhibit the norepinephrine transporter or all three norepinephrine, dopamine, and serotonin transporters based on its optical rotation. Amphetamine was found to inhibit norepinephrine and dopamine transporters as well. Thus, similar symptoms between benzofury and amphetamine and ecstasy may be due to their common actions as indirect antagonists at these sites. Moreover, as you can see from these three graphs, 5-APB and 6-APB causes release of neurotransmitters when at high concentrations, just like MDMA does. For convenience's sake, I've highlighted the relevant bars in red. This figure comes from another paper by Rickley et al. 2015 and was done with 100 micromolar concentrations of the drug applied to ATK293 cells, overexpressing the transporter in question and containing radio-labeled neurotransmitters. 5-APB and 6-APB do seem to have a more unique functionality, however. In addition to their effects of monoamine transporters, 5-APB and 6-APB appear to be full agonists at the 5-HT2B receptor. In this graph, published in the same Iverson et al. Paper as earlier, one can see the efficacy of 5-APB and 6-APB is not as much as 5-HT itself, and their potencies are lower as well. However, the maximum efficacy is high enough to be considered full agonists for both these drugs. The 5-HT2B receptor is not as thoroughly studied as the classic 5-HT2A receptor, and as such it is difficult to ascertain the full effects of 5-APB and 6-APB at this receptor. It is, however, thought that the 5-HT2B receptor mediates vasoconstriction and serotonin release via the serotonin transporter. Increased release of serotonin, though, through this receptor could explain another aspect of the drug's similar functionality to MDMA ecstasy. From a 2014 paper by Dawson et al., 5-APB's effects on preparations of fundus, an area of stomach, were investigated. This preparation was used as it is thought to be a good indicator of 5-HT2B receptor function as described by Sir John Vane. In the left graph, you can see 5-APB has a higher effect on contraction of fundus than MDMA, but less than 5-HT. The right graph shows this effect is extinguished by 5-HT2B receptor antagonist RS127445. Drug function at this receptor is thought to underlie heart valve fibrosis, and indeed, ecstasy does seem to cause heart valve fibrosis through this receptor. Finally, the same Dawson paper examined 5-APB binding in different brain areas. In both progressions of images, decreased signaling is associated with higher 5-APB binding. This helps identify areas of the brain where 5-APB binds and how it produces its effects. Binding to a dopamine transporter in the caudate and nucleus accumbens appears to be the mechanism through which 5-APB acquires its addictive effects. Binding to the 5-HT receptor in the nucleus accumbens and prefrontal cortex appears to be the mechanism through which 5-APB acquires its hallucinogenic effects and possibly partly its vasoconstrictive effects. In conclusion, benzofury is a recently emerged synthetic drug with a variety of effects short-term and long-term due to the lack of research on the drug. Short-term use appears to cause euphoric effects and hallucinations with a variety of other effects resembling ecstasy and amphetamine. Long-term use symptoms are mostly unknown, but consistent use of the drug may lead to heart valve fibrosis, as does ecstasy. Concerning its neurochemistry, benzofury functions through its inhibition of norepinephrine, dopamine, and serotonin transporters, and through its binding to the 5-HT2B receptor, and through 5-APB's binding to the 5-HT2A receptor. And finally, here are my references. Thank you for listening.